to this point, we have dealt with right triangles and right triangle trigonometry, but we can also use trigonometry to solve, or in other words, find the unknown pieces of non-right triangles using either the law of sines or the law of cosines. And which one of those two we use depends on the information that we are given. The first section that we're going to talk about is when we are given two angles and one side of a triangle. And in this case, we use what we call the law of sines. And what the law of sines tells us is that if you take the sine of an angle divided by its corresponding side opposite, so in other words, if this is angle A, the side opposite angle A is here. This is angle B, this would be side B, this is angle C, that would be side C. So the ratio of the sine of an angle to its corresponding side, those ratios are equal for any triangle. Now, that's one way to look at it, but you could also look at it as the reciprocals. So if you have A over the sine of A, that will equal B over the sine of B, and that will equal C over the sine of C. So in this particular case, we want to find we want to determine the remaining sides and angles of the triangle, and we are given that angle A is 33.9 degrees. Angle C is 97.6 degrees, and side C is 69.9 feet, sorry. So one thing that we can quickly find is angle B, because anytime you know two angles in a triangle, you can subtract the sum of those two angles from 180 to find the third angle. So angle B will be 180 degrees minus 33.9 degrees minus 97.6 degrees, which will end up being, let's see, 48.5 degrees. Now, we also want to find side A and side B. Okay, so as much as we can, we're going to use given information. So to find side A, since I'm looking for the side, I'm going to use this version of the law of sines. I will have A over the sine of A is equal to C over the sine of C, since we were given the information about both side C and angle C. So I will have A over the sine of 33.9 degrees is equal to C over the sine of 97.6 degrees. So that will give us that A is equal to 69.9 feet times sine of 33.9 degrees divided by sine of 97.6 degrees. Plug that in. Make sure your calculator is in degree mode before you get going on that. So we'll have 69.9 times the sine of 33.9 divided by the sine of 97.6. And I'm getting 39.33. So that will give me that A is approximately 39.331829 feet. And we're going to round to the same number of significant digits that we have here, which is 3. So that will be approximately 39.3 feet. So we've solved for side A and angle B. And so all that's left to solve for is the side B. So I'm going to use C over sine C again. So I'll have 69.9 feet over sine of 97.6 degrees is equal to B over the sine of angle B, which was 48.5 degrees. So B will be 69.9 feet times sine of 48.5 degrees over sine of 97.6 degrees. So when we plug all that in, we will get B is I'm getting B is 52.8 feet. And I just went ahead and rounded that to 3 significant digits. Okay. Now, one thing you can use to check, it's not an absolute check, but at least gives you an idea if you're in the ballpark. It's always true that the biggest side is opposite the biggest angle, the smallest side is opposite the smallest angle, and the middle side, length side, is opposite the middle sized angle. So we look at this, our angles are A, B, and C, where B was 48.5 degrees, A was 33.9, and C was 97.6. We got that side A was 39.3 feet. We got that side B was 52.8 feet. So at least that's consistent. The biggest angle is C and the biggest side is C. The smallest angle is A and the smallest side is A, and similarly the middle angle is B and the middle side as far as length is concerned is also B.